Hi, this is Miss Jensen, and today we are going to do an introduction to radians. So there's two goals for today, kind of three. We're going to start out with just understanding where radians come from, but then being able to convert radians to degrees and vice versa, and also graphing an angle in standard position and finding the reference angle in radians. Okay, so we're going to start out with a little introduction of the unit circle in radians. So this is, if I kind of just look at this circle, unit circle in radians, you guys are probably familiar with 2 pi or pi. Pi is half a circle. 2 pi is a full circle. So 2 pi, if you think about circumference, circumference is given in terms of pi. So a full circle is 2 pi radians. So just like degrees, I can start this in 0, but if I go a full circle, except there's no degrees there, if I go a full circle, that is 2 pi. So then what would half a circle be? Well, half of 2 pi is 1 pi, okay? And we know that that's the same as 180 degrees. This is the same as 0 degrees or 360 degrees. And then if we think halfway between 0 and 1, so degrees wise, we know this is 90, but half between 0 and 1 is 1/2 pi, which is the same as pi over 2. So 1/2 pi is the same as pi over 2. And finally, halfway in between 1 and 2 is 1/2, which if I change that to an improper fraction, it's 3 over 2. So this is really the same as 3 over 2 pi. That is halfway between 1 pi and 2 pi. And that is equivalent to 270 degrees. Okay? So there we're just dividing the whole circle from 0 to 2 pi, because a full circle is 2 pi radians. We're dividing it in half and then really into fourths. What's half of 1? 1/2. What's halfway between 1 and 2? 1/2 or 3 over 2. Okay, now we're going to continue to divide the top. So we're just going to worry about the top half of the circle, and then we're going to kind of see how, where the unit circle in radians is coming from. So remember we talked about this is 0, this is pi, and this is pi over 2, okay? Well, we can divide that further if I want to divide it into thirds. So if I want to divide the whole thing into thirds, I can think of this as 1/6, which is 6 over pi, 2/6, 3/6, I'm going to change this to 3/6 actually. 3/6, which is the same as 1/2 pi, 4/6, 5/6, and 6/6. Well, if you look at what the unit circle is, if we simplify that, 1/6 is just 1/6, 2 over 6 is 1 over 3, 3 over 6 is 1 over 2, 4 over 6 is 2 over 3, 5/6 can't be reduced, and 6 over 6 is the same as 1 pi, okay? And you can continue on with the bottom half as well. We could continue on after 6/6 to go 7/6, 8/6, 9/6, 10/6, 11/6, 12/6, and again 12/6 is the same as 2 pi. All right, so when we look at that unit circle, when you see a picture of the unit circle, that's what we're thinking of. We're taking half a circle, which is pi, and we're dividing it into 6. All right, and then the last thing is we can also well, I guess this is just repeating. If we divide it into thirds, if we want to talk about it that way, if I divide it into 3 parts, we already kind of did that, but if I divide it into 0 and pi, we can go 1/3, 2/3, 3/3. And again, we get the same thing we did when we divided into 6, right? So the exact same thing. But, you know, that's really the same as dividing it into 60-degree chunks. Okay? Now we're going to talk about dividing it into fourths. So by the same token, like if I start here with 0, except I don't want to meet degrees, I keep wanting to put degrees. 0 and pi radians. Again, I'm going to divide it in half. And actually then from there, I'm going to divide it in half again. So I'm going to divide it into fourths. So I'm going from 0 to 1. 1/4, 2/4, 3/4, and 4/4. And you can see we get pi over, or 4/4 is the same as 1 pi. 3/4, 2/4, 1/4, and back to 0. How that matches up. But just really when we go by 45s, we're just dividing the top of the circle and for that matter, the bottom of the circle into fourths. So again, I can kind of continue on from 4/4, 5/4, 6/4, 7/4, and 8/4 again is 2 pi. But that's really where this unit circle that we see is coming from. All right, so that's background on the unit circle. We're going to kind of go to the second objective here, which is converting degrees to radians. So converting degrees to radians. I'm actually going to go to that there. That's a better picture. So 1 degree is equal to 180 over pi degrees, which is about 57, it's about 0.017 radians, okay? So if I did 3.14 divided by 180, I would get 0.017 radians. 1 radian is the same as 180 over pi. So if you think about 180 is half a circle, pi is half a circle. So this is almost like half a circle over half a circle, which is 1. But if I did 180 divided by 3.14, I would get 57.3 degrees. Okay, this is really the main thing you need to know, is that degrees over degrees is the same as radians over radians. And that's how we're going to convert degrees to radians. By the way, if we wanted to know what 1 radian was, 1 radian, what it looks like, it's like a pie chunk. So 57.3 degrees might look like that. So this is about 57.3 degrees. And if we colored that in, that pie chunk is equivalent to 1 radian. So just kind of so you get an idea of what we're talking about with radians. It's like pie chunks. So how many pie chunks are around, you know, the circle? Well, remember pi is the same as 3.14. So by the time we get here, there's 3.14 pie chunks. By the time we get all the way around, there's 6.28 of those pie chunks. So 6 full pie chunks plus that 0.28 left over. Okay, this is really what we're going to use here, is degrees over 180 equals radians over pi. So if I want to convert degrees to radians, I'm going to use that proportion that we were just looking at, which is degrees over 180 equals radians over pi. So I want to make sure that I put degrees over degrees and radians over radians. Well, 180 is degrees, so I'm going to put 330 here, and I want to know how many radians. So 330 degrees over 180 equals x over pi. I'm going to go ahead and cross multiply that. So if I cross multiply, I get 180x equals 330 times pi, which is 3.14. But we're just going to keep it like that, actually. Because remember radians, when we look at the circle, it's actually a fraction. Okay, so that's more or less my answer. It's 330 over 180 pi, but I can reduce that fraction. So notice that 330 over 180 reduces to 33 over 18. And for that matter, I can divide the top by 3, the bottom by 3, and it's equivalent to 11 over 6 pi. So if I went back to one of these unit circles here, remember we were converting 330? Well, 330 is the same as 11 pi over 6. So if we don't have a unit circle next to us and we want to convert it into radians, this is how we do it. And it's the same going backwards. So again, I want to convert degrees to radians. So I'm going to put 180 in the denominator of one fraction, pi in the denominator of another. This is degrees. I will put that there. I will put x here. And again, I will cross multiply. Okay, so we'll go 180 times x equals negative 60 times pi. We'll divide both sides by 180. And I can reduce 60 over 180 to 6 over 18. And then I can reduce it even further. Divide the top by 6, the bottom by 6. And usually we write it like this. You can just put 1/3 pi, but usually we just put the pi on the top, bottom on the bottom, or sorry, pi on the top and the number just on the bottom. So negative 60 is equivalent to negative pi over 3. So again, if I kind of go back here, negative 60 is coterminal with 300. So this is 300 degrees here. And it's equivalent to 5 pi over 3, or negative 1/3 is how far we went back. All right, so converting degrees to radians. I think we'll just skip this one. If you want to look at the hard copy of the notes, it's in there, but it's the same idea. Okay, so now we're going to convert radians to degrees, and we're going to do it the same way. We're still going to put 180 on the first denominator, pi in the second, but now because they gave me radians, I'm going to put 2 pi over 3 here, and I'm going to put x here. Now what happens when I put 2/3 pi over pi? The pi over pi crosses off. And I'm just left with a fraction of 2/3. And now I'm going to cross multiply. So I'll go 3 times x equals 2 times 180. So we cross multiply. And we get 360 divided by 3, which should be equivalent to 120. Okay? So 2 pi radians is equal to 120 degrees. So if I were going to sketch that, this is 0, this is 180. This is also equivalent to pi. But again, if I sketch that out, 2 pi, this is 1/3, 2/3. 2/3 should be equivalent to 120. Remember, 1/3 is equivalent to 60. So again, just trying to get the idea of how the radians circle is, the top is really just divided into thirds, or it's divided into sixths, or it's divided into fourths. Okay, Let's just do one more of those. We'll do the 7 pi over 4 because it's the same process. So we'll put 180 pi. I guess I'll make that into, we'll do 7 pi over 4. We'll put x here. And again, pi over pi is going to cross off. So we're left with x over 180 equals 7 over 4. And then we cross multiply. X times 4 is 4x. 7 times 180. We'll divide both sides by 4. And we should get 7 times 180 times 4 is 315. So 7 pi over 4 is equivalent to 315. And again, if we were going to draw that, so this is 0, 1 fourth, 2 fourths, 3 fourths, 4 fourths, 5 fourths, 6 fourths, 7 fourths, and that is equivalent to 315. Okay, you don't have to draw the circle like I'm doing. I'm just trying to show you that, you know, if we kind of count around, it truly is the same thing. All right, I don't think we need to do another. Again, you can look at a hard copy of the notes if you want to see a couple more examples. But again, whether you're going degrees to radians or radians to degrees, you're going to go degrees over 180 equals radians over pi. And if they give you radians, you put it over pi. If they give you degrees, you put it over 180. Okay? All right, so the last thing here is graphing and finding reference angles for the following. So there's two different ways you can do this. Like if you really are struggling with how to do this in terms of pi, you can change this to degrees and do what we were doing in the last unit, you know, find the reference angle, and then change it back. But, you know, we're going to try to think of it in terms of radians, okay? So graph and find 4 pi. So if I go 4 pi, this is 0 pi, this is 1 pi. You know, so if I'm just sketching, this is 1/3 pi, 2/3 pi, 3/3 pi, and 4/3 pi. Okay, so that's, I'm going to draw the angle. So that's where the angle is, goes all the way to here. But then the question is, what is my reference angle? What's my reference angle right there? So just like before, I'm going to go up to the x-axis, and a reference angle is how far is that angle from the x-axis. So my reference angle, it's like a distance. So I'm going to take the bigger number minus the smaller number. And I get 1/3 pi. Okay, now if I were doing this in degrees, this would actually be equivalent to 240. This would be equivalent to 180. You know, if you just really have a trouble with thinking in radians in a circle, try to think in radians, however. But if you absolutely can't, then you can always convert it to degrees. I would get 60 degrees here. This is the same as 60, this angle here. And then I could convert 60 back to radians again, okay? But this distance here is pi over 6. Pardon me, pi over 3. Pi over 3 is the reference angle. We'll look at another one here where it's actually negative, so it's a negative angle in radians, negative 7 pi over 6. So just like degrees, we like it between 0 and 360. With radians, it's probably easier if it's between 0 and 2 pi. So if I have a negative, I want to add a full circle. I want to add 2 pi, and 2 pi in terms of sixth, 2 pi is equal to 12 over 6 pi. Not 16, 6. So I can add 12, 6 to this, and I get a coterminal angle. So negative 7 plus 12 is 5 pi over 6. Okay, then I'm going to go ahead and divide this into 6. I want to get to 5, 6, so this is 1, 6, 2, 6, 3, 6. 3, 6 is the same as pi over 2. 4, 6, 5, 6. 6 pi. I'm trying to get that here. Okay, and just like before, now that we have the angle, this is our angle, we want to draw a line to the x-axis, and we want to figure out what this angle is here. How far is it between 5, 6 and the x-axis? So we're basically figuring out the distance between 6 pi over 6. How far is it from 5/5 to 6/5? And it's 1/6. Hopefully I said that right. 6, 6 minus 5, 6. But this is the reference angle. This reference angle right there is pi over 6. Okay? So if I were doing that in degrees, of course, this would be 150, and this is 180. Well, the reference angle between 150 and 180 is 30. And 30 is equivalent to 2 pi over 6 in radians. So if you really don't like working in radians, you can convert 5 pi over 6 to degrees, figure out the reference angle is 30 degrees, and then convert it back. Okay, we'll just do one last one. You know, once again, this is not between 0 and 2 pi. 2 pi would be 8 pi. So I'm going to go 15 pi over 4 minus 2 pi. This is equivalent to 2 pi. And now this is 7 pi over 4. So this is 0. This is pi. This is 2 pi. If I want to do it like this, 2 pi is the same as 8 over 4. Because I'm going to divide it into fourths here. And I'm going to go all the way to 7 pi over 4. So this is 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4. And my reference angle, I'm going to go up to the x-axis. So that's my triangle. And I want to know how far is it from 7/4 to 8/4. And it should be 8 minus 7 is 1/4. So that is the reference angle. The reference angle in radians is pi over 4 radians. That's the same as 45 degrees. Okay, that is all for this lesson.